Alrighty, welcome to Dave McComb's session, Data Centricity. Dave wrote two bestsellers that we at Technics Publications published, Software Wasteland and The Data-Centric Revolution. They're both amazing books. Somebody came up to me at a conference a couple years ago and said that he actually he used the word devoured the book. He loved every paragraph. Dave is the president and co-founder of Semantic Arts consulting firm that helps organizations uncover the meaning of data from their information systems. Dave co-founded Velocity Healthcare, where he developed and patented the first fully model-driven architecture. And with that, welcome, Dave.
Great. Thanks, Steve. We got a lot of material here, so I'm just going to leap right into it. We're going to shine the data-centric lens on the big three of metadata, being ontologies, taxonomies, and schema. You know, how do we, everybody hears about these all the time. How are we going to bring them together? It's not a us versus them or anything like that. It's how are we going to bring them together? So here we go. So here's how this presentation is going to go. You know, even very briefly, what are the big three? You know, what's the difference between schema, taxonomy, and ontology? And then what is data-centric and how are we going to use that approach to unite those three? A little bit about how you start the journey of becoming data-centric, and then some crass promotion at the end. And Steve is going to help us sell some books here with a 60% discount, but stand by. You got an hour to get, or 40 minutes or whatever it is to get there. So what is metadata? You know, this is the classic. Everybody says the definition of metadata is data about data that provides information about data. But, you know, while that is probably literally true, when you peel it back just a little bit, you start realizing, oh, we mean different things in different contexts. You know, for instance, in relational, metadata tells you what the structure is, how things connect, what the field names are, but especially how you could join them, and what is it even valid to say? What can you say about a product? Well, you can say it has a merchant, the name, and a price, things like that. That's metadata in the relational world. In that, you know, if you ever dealt with content management people, when they say metadata, at first you may think they're talking about the same thing, but they're not at all. You know, a relational person would think the metadata of email is the word from, the word to, and the word subject. But people in the content management space say, no, the metadata is who it's from and who it's to and what the title is. You know, it's the data about the document, if you will, the author, the actual author, not the name, not the word author. Taxonomies are, you know, almost any indented list these days becomes a taxonomy. This one on the right, I just randomly went looking for some. This one on the right, people would call it a taxonomy. It's really locations, you know, it's counties. That's not typically categories, but people treat them that way. The one on the left is something else, but, you know, people very often put things in very large indented lists to try and organize their body of knowledge. Many people start down their data-centric journey with taxonomies, but there's a trap there. Almost everybody wants to be the next Carl Linnaeus or Melvin Dewey. Carl Linnaeus was the Swede that invented the tree of life, you know, the genus and species and all those things we have now where there are, you know, hundreds of thousands of species just of mammals and animals and millions more on the other single-celled side. But the problem when you try and bring that, and Melvin Dewey, obviously the Dewey Decimal System in the library, and the problem when you try and bring that into the enterprise space, people want one tree to rule them all, like the tree of life or the Dewey Decimal System, but it really doesn't work. The longer you stare at these things, you start seeing just because you can make an indented list doesn't mean that it means the same thing all the way up and down. So that's just kind of a caveat. And then the last thing is an ontology is metadata about meaning. It's not about structure and how do you join things. It's what do things actually mean. I'll give you a very brief example here. Let's say we decided that a patient is a person who receives treatment at a medical facility. Seems like a reasonable. Many of the healthcare organizations we've worked for would buy into that. Semantically, what that says is we have Venn diagrams, if you will. When we say it's a person, we mean that there is the set of all persons, all human beings. When we talk about receiving treatment, there's the set of all things that receive treatment. Now, something like an animal may receive treatment, but not be a person. So it could be in that green that's not in the red. And if you're a patient, if you receive treatment at a medical facility, if a good Samaritan gives you treatment on the side of the road, that doesn't make you a patient. And then furthermore, how you know the little smaller blue square is the medical facility, the bigger blue circle is being treated at the medical facility. Same with the smaller red circle or green circle is a type of treatment. You know, there's a CPT code for these in healthcare. That would be the CPT code. The bigger green circle is something that received treatment. So something that's in the center of all those, that's semantically what a person is. Now, of course, when you go to implement that, you may say, well, yeah, but we want lots of other data about a person. Yeah, of course you do. The admitting people want billing information. The treatment people want a whole different set of information. They want blood pressure and vital signs and all that kind of stuff. But, you know, this is sort of at the core, what's different between schema, taxonomy, and ontology. And then we're going to figure out how to knit those back together. But before we get into the thick of this, you may be wondering, who is this guy and where did I get all these strange opinions that I seem to have? Here's where they come from. As Steve briefly alluded to, 21 years ago, we co-founded Semantic Arts, mostly based on what we'd learned previous company, Velocity, where we were creating model-driven applications in the healthcare space in a .com, which of course we blew up on the IPO launchpad in the winter of 2000, as many people did. Prior to that, I was with Accenture, well, actually Anderson Consulting, the part that became Accenture, traveling around the world, building and implementing enterprise information systems. And as I say, I was actually part of the problem. You know, we did some great work, built some great systems, but after a while, I realized that we were creating this problem we now call systems integration or integration debt. But anyhow, when our .com blew up, we didn't have access to all our patents and technology and all that stuff. So we started consulting. Right after we started consulting, Tim Berners-Lee launches this thing called the Semantic Web. And we're thinking, wow, man, this is perfect. He launched the World Wide Web, 10 years ago, and everybody was first in line for that, did so well. We're going to do well. Now, we just sat there. Nothing happened. I wrote a book in 2003, which didn't make a dent at all. It's hardly noted. We started a conference in 2005, joint with Tony Shaw of Dataversity. And at least in that time, got to know everybody in the space and honing our craft, even though people weren't really picking this up very rapidly. But then right around 2012 or so, we went from designing to implementing. We finally realized that people weren't implementing what we were designing. As we started implementing, we came up with this concept we call data-centric, a data-centric way of implementing. I wrote, as Steve mentioned, Software Wasteland and then the Data-Centric Revolution. There are a number of companies that are on this journey. It's a very long-term commitment for if you're a large company. We're just starting to come down market to some smaller companies who have a different offering for that. But here's Semantic Arts. It's all we've done for 21 years is semantics and knowledge graphs. We've built at least 50 enterprise ontologies, which is a model of an enterprise. We've got 25 employees now, which makes us probably one of the biggest collections of ontologists. They're a bit rare. And we have a upper ontology we call GIST. It's on our website. It's free. You can just go there. It's a very excellent starting point if you're you want to get on this journey. Here's some of our clients who were on the journey in one way or another. Of the names you would probably recognize. Here's some of them, either it's a name you'd recognize, but we've only done a very small project for them, or a name you wouldn't recognize and we're doing a more significant project with them. But there's a number of people who are on this journey. So here's our contention in a nutshell. This is kind of my software wasteland pitch. The way people are developing, especially implementing systems, means they cost way more than they could cost or they should cost. They're brittle, hard to change. And it's the act of creating yet another system and creating yet another arbitrarily different data model that is what's creating the systems integration need, which shouldn't be needed anyway. So by the time you've done this for decades, as most large firms have, you end up with this thing they call enterprise architecture, and enterprise architects always draw these things with lots of boxes and pieces of middleware and systems all over the place and buses and all that. And we used to help clients draw a picture of what they created, because many of them couldn't. But after a while, we said, redrawing the same picture over and over again, they always go, oh yeah, I hate that. But I had an artist look at a series of these and create a kind of a composite artistic sketch. This is it. You might recognize it if you're in a large enterprise. That hairball in the middle is your ERP system. The thing down at the bottom is your enterprise message bus. You've got your data warehouses over there on the right. See that new little thing there? That's Snowflake. And you've got Talent over there, MuleSoft, and hundreds and dozens of applications with different ways of connecting them in. It all runs beautifully. So what caused that was, traditionally people would say, we have a business problem, we have a decision to make, we have to either buy, build, or rent now, because of software as a service, you can rent a solution and that will solve our problem. But every time you do that, you get yet another data model. And here's a case, with social media and all these things, people talk about network effects as if they're a good thing. Network effects on systems integration is a bad thing. Every time N goes up, if N is the number of systems that need to be integrated with each other, the cost of integration goes up by N times N minus 1. And we call this integration debt. And it seems inevitable, but it isn't. That's how people have been doing things for a while. The other way, we call it data-centric. We're going to kind of go into what that is and finally how it's going to reconcile all this. There's a lot of buzzwords floating around. There always is, there always will be. I want to distinguish data-centric from just a marketing buzzword. It has a very precise meaning. We're going to get into it. But you've probably heard about data lakes and data fabrics and data meshes and the latest one is the data lake house. That's a data lake with a warehouse in it. Don't ask. So what data-centric is that's distinct from those, because frankly, go do some searches on any of these and you'll find white papers and stuff, but the longer you read them, you just kind of scratch your head and you go, what exactly is that? So data-centric starts with the data model, not starting with a business function or a process that you're trying to automate, which, by the way, Agile typically starts with the user story, which is a business function or process, and then the data is created along the way, which is partly what leads to this. And then the scope of a data-centric system is the enterprise. So typically the scope of an information system is the application. When you change your scope to the enterprise model at that level, you have a hope of creating integration as you go. Or sometimes we say integration almost for free. So here we go. Here's my more specific definition, and it's a run-on sentence. It's got a lot of adjectives, but I'm going to unwind all of them. And we say to the extent, because when you begin the data-centric journey, your whole company is not suddenly data-centric. This is something that occurs over time, done well. It's what one of our clients calls a self-funding journey. But we say that you're data-centric to the extent that your application functionality is loosely bound. So in a traditional system, application logic is incredibly tightly bound to the schema. If you've ever looked at a lot of application code, almost every other line refers to some piece of the schema, directly or indirectly, through an API or directly to the tables or whatever. But there's always, if the social security number is this, or if this flag is that. So here we're saying, no, we got to get away from that, loosely bound, to a single, simple, extensible, federate-able, universal, shared, and directly implementable model. So one at a time. When we say single, so on the left, we're going to distinguish that from what exists right now, the traditional enterprise architecture, one data model per application, and very often thousands of data models. In a data-centric architecture, there's a single, simple model at the center. And there, as we'll get to in a minute, there are variations, but this is where we're starting from. Simple. Traditionally, every application is thousands of concepts. And when we say a concept, anything that you need to know to use that system, the table, the column, any of that typical metadata is things that the designer and the querier and even the end user, unfortunately, every field that comes up in a form that you have to fill out, somebody has to know, oh, what does this field mean? Any enterprise of any size has millions of concepts. Many, we work with some data profiling companies, find hundreds of millions of concepts under management. It's kind of mind-boggling. Every place we've been so far, the core, the thing that holds everything together, has rarely more than 500 or 1,000 concepts, even the seemingly incredibly complex enterprises. So that's when we say simple, that's what we mean. Extensible says, and this is, I don't know why there it goes. In a traditional system, there's no mechanism for extending a model. So if you have a big legacy system and you want to add 3 attributes to it so you can categorize your customers between VIP and VVIP or whatever people always do with their rogue software, what you do right now is take an extract, put it in Excel or Access or citizen developer tool of choice, and then add those handful of columns and do some analytics. But that's not extension. That's cut and paste and copy and add on and yet more ad hoc integration. In this world, you can either directly implement what's in the core model or make some very small extensions, but still use the central model and functionality. So for instance, in this case, if the core had the concept of inventory, which most do, somebody in one little department might have hand tools where you have to keep track of who you checked it out to and when is it due back in and when is it inspected, which the rest of the enterprise doesn't want to have. But you can just extend everything else about inventory, costing still works. Or somebody else wants to do fresh produce. They have a use by date or fresh best by date. Then nobody wants that for jackhammers and screwdrivers and stuff. So they just make a local extension there. This idea of federate-able, in a traditional enterprise, it's really way too hard to federate anything, meaning have one query go over multiple systems. And so the solution for the last 20 or 30 years has been co-locate data. So use ETL, take it from all those systems, put it in one place, because we can only pretty much query from one place. There's occasionally these virtual databases, but it's a very edge case. And that, by the way, that's the same logic that led us to the data lake. We don't know what this stuff means, but at least we put it all in one place, we have a hope. Well, no, you don't have a hope, actually. If you don't know what it means, you're kind of screwed. These technologies, you can query the core model at the center there and it can reach out into the existing systems, and at query time or at ETL time, but right now we're talking about query time, interrogate that data, make it compatible with the enterprise ontology, and return a result that came from multiple systems. When we say universal here, This has been the holy grail for decades, and it's now finally here, although people seem to be shrugging and saying, whoa, who needs this now? So on the upper, I guess I got my timing out of place here. There's no good way to unify disparate data. You've got some of your data is in relational, and some of it's in JSON, big data, and some of it's still in documents, and some of it's, in networks and whatever. As we'll see in a few minutes in the presentation, in the upper right-hand corner, there's some structured data. There's a way to turn that into a common format that we'll see in a few minutes, called a triple. In the upper left-hand, we're depicting semi-structured data. It could be XML, JSON, HTML. In the lower left-hand corner, there's data that already exists as a graph or a network, like social media, LinkedIn, anything like that. And the lower left, even unstructured, we can do two things there. One, we can harvest the so-called metadata from content, the author and the date and the publisher. But we can do much better than that. Read the text, find the named entities, find the relationships between the named entities, and conform them to the model and to this particular structure. And now you've actually done something. In a traditional system, there's no actual mechanism for sharing data. You copy and paste it and have Kafka streams or whatever it is, the mechanism of choice now. But you move data around to share it. In this environment, this is a little snippet from Google's knowledge graph, and everybody uses Google now, but the fact that they're using these approaches, I think, is a pretty good endorsement. The idea is designed well. You have a graph of some part of your business, let's say all the employees and where they work in the organization and billing rates or whatever. Other people can just use that as it is. They don't have to conform it to their own local structure. No, just use it as it is, share it. And then finally, we've been taught for decades this idea on the left. Well, many people think something as simple as what I'm describing here, 500,000 concepts, surely you're talking about the conceptual model, and that eventually you're going to have all this extra detail when you finally get to the real model. Which on the left, we had conceptual, it becomes logical, it becomes physical. And there's a whole, industry around doing that. In this world, and it took us a while because we had bought into that picture on the left. It took us a while to realize, if you do this properly, you build the conceptual model and then you just populate it. There is no, the conceptual, logical, and physical are all one and the same. It has all the requisite detail. There's nothing else other than occasionally setting which indexes you want to use if you want to speed things up, but that's pretty much it. So that is what data-centric is. If you buy into that at all, the next question is, well, that sounds sort of fantastic, or at least good, or maybe interesting. How are we going to get from where we are now to there? We've watched a lot of people do this. We used to have a questionnaire, we probably do somewhere still, I forgot where it is, where people would, so you think you're already data centric? Because whenever there's a buzzword, people, the immediate thing is, oh yeah, that's us. Well, not so much. But we had somebody answer the questions, they got 8 out of 10, whereas most people get 2 or 3 out of 10. And I couldn't believe it. I went and interviewed them, and I flew out there and met them, and sure enough, it had taken them quite a while, but they had their entire enterprise on a single model. It wasn't simple, like we're advocating here, but the fact that they did it at all was quite incredible. But what I'm going to describe here is a simpler way than the way they did it. I mean, it took them almost 2 decades, and it was partly possible because the company was small when they started and it grew with it. It's harder to do this in an established company, but not impossible. So here's the 3 legs to the stool that we think make it a lot easier. Like I said, this other company only used the lower right-hand one, but and they managed to get there. So it is possible, just more difficult. So let's talk a little bit about what each of these is. A knowledge graph or a graph database, either one that we use the terms interchangeably. Some people, pick nits to separate them, but it's has three, I think, pretty incredible advantages. One is flexibility, which we'll see in a minute. Two is you get your integration almost for free. And this is how you begin getting rid of data silos. So a knowledge graph or a graph database, imagine on the right, that's a traditional relational database. This is the secret agent database for James Bond and all those guys. And I like to use this example because it kind of brings home this idea that, yes, all systems, including relational systems, have identifiers. So in this case, James Bond is 007. But the problem with a traditional system is the identifier is hyperlocal. The identifier only means James Bond in this database, this table, this column. If you have a cafeteria, 007 might be a ham sandwich. I mean, and the problem is humans have to know, oh, wait a minute, agent ID actually snaps together with weapon assigned to, but not, sandwich and all that kind of stuff. So one of the ways we finesse that here, and it's kind of abbreviated, I've just got these colons in front of the numbers, but these things have globally unique identifiers such that we can snap things together without having to know anything about their metadata. So 007 in this world, imagine that it's actually https:// Her Majesty's service.uk.org/agents_007. Whenever you encounter that exact URI, you're talking about James Bond. But more to the point here, anything that can be represented in a table can be represented in this simple structure here called a triple. There's a subject on the left, an object on the right, and a relationship between them. And you can imagine every cell actually represents a triple, whereas the subject on the left is the row, the concept, the column is the predicate in the middle, and the object, in this case Bond, is on the right. So everything eventually can get reduced to the single format. The flexibility is as you learn more things about James Bond, you just add more information. It doesn't have to previously had a table or any kind of structure. Some people talk about schema on read, meaning trying to distinguish between, do you have to have the schema in place before you can write any data? In this case, we have an interesting combination of, we call it schema later, but as you discover that, if a secret agent that's been issued a Rolex is some other, that you can apply something else, well, there you go. And this thing can extend indefinitely. You've seen lots of pictures. Those complex graph visualizations we're just adding more triples on. In this case, we discover from somewhere else, maybe even literally a document, that particular Rolex watch number 23, has the Garrett in it. A different one may have a poison pill and all that kind of stuff. And you just keep extending. That's where the flexibility comes from. A little warning here. Gartner just recently said artificial intelligence, which is already hyped, within the overhyped artificial intelligence space, knowledge graphs right up there at the peak of inflated expectation, is about to become, hyper hyped, I guess. And of course, we know what happens when Gartner announces this. Once you're at the top of that roller coaster, it's all downhill from there into the so-called trough of disillusionment. Things sink into the trough of disillusionment, not because there's anything wrong with them, but because Gartner hypes them and everybody rushes in and puts this on their marketing material and their resumes, and they rush in claiming to be able to do this. And of course, they don't know how, and bang, a whole bunch of clients get upset. But then eventually that washes out and you finally get to the plateau of productivity. I mean, that's what's about to happen with knowledge graphs, mark my word. So the second technology that helps a lot is semantics. We touched on it very briefly. It's the study of meaning. There is a standard that's been around almost for 20 years now for formally expressing what meaning is, what it means. And if you build a model in OWL, we call it an ontology. It's like an enterprise data model without all the complexity. You know, we've looked at a number of enterprise data models over the years. Almost everyone has given up on attempting to build them because they get too big and too complicated and too brittle. And besides, everyone was buying packages anyway and ignoring us. But this is what an enterprise data model would have been if it could have worked. So our contention is that when you really study something and find out, you know, not just listen to a subject matter expert, write something down and say, it looks like another table, another class, and on you go. But the deeper you go into the meaning, the simpler things get. It takes a little while, and the other thing you get with semantics is inference, the ability to derive new information from the information you've got automatically. And then finally, we've got this idea that you can model drive, you can create a model-based representation of most of the functionality of most systems. You know, let's face it, most enterprise application systems are about, you know, 80% forms and tables and graphs and a handful of things that we just keep writing over and over. I mean, how many accounts receivable, invoice capture systems have been written, and they're all the same, except all the names are different and the language is different, all that kind of stuff. Turns out, you know, this is what we got our patents for back in the 90s. We've done this many times. It's a little bit different sitting on top of a graph. We were not doing that in the 90s. But, you know, we know with a lot of certainty, most of the code in most applications can go away. So let's take a look at a kind of a simple example and how it finally unifies the ontology, taxonomy, and the schema. That was what I was advertised to talk about at the beginning of this talk. So imagine there is an ontology here in the middle in this blue cloud, 500 or 1,000 concepts. And then what we do, and one of the ways you get the number of concepts down, is anything that doesn't necessarily need to be structurally different in your model. So let's say you have people in your model and you decide, well, some are males and some are females. That can be a taxonomy. That's a very small, simple taxonomy. It is not, you know, Melvin Dewey in the Library of Congress or anything like that. That's just, can we distinguish males from females? Now, in about 95% of every enterprise that we've been in, that's as much distinction as you need to make. You don't need a separate class for males and females. If you're an insurance company and you underwrite differently, you know, males are more reckless and therefore their premiums are higher. But structurally, there's no different information you're capturing. You know, you're still capturing the number of accidents they've had and all that stuff. You know, the handful of places where it is different, you know, if you're in an OB/GYN clinic or a urology clinic, which we built a system for, yeah, of course, you would have a class for male patients and female patients because there's a whole bunch of different questions and attributes and concepts that are gonna be different. But in a lot of cases, all you need is the taxonomic distinction. Things like, you know, age, you might have a taxonomic version, or you might literally have their age. But this is the beginning of how taxonomies and ontologies fit together. Unfortunately, usually people build these gigantic trees and then bring them into the ontology and say, let's start there with those as classes. It doesn't end well. The next thing, you know, as you start to extend your domain, you add a few concepts. Maybe in this case, this was the payroll, you know, you had a ontology of an enterprise and you wanted to do payroll. Well, they have to introduce the idea of exempt versus non-exempt. Maybe not everybody in the firm cares about that distinction. Maybe they do. If they do, you move it up. If they don't, you leave it where it is. Again, an ontology extension with new taxonomies. Now, these things at the bottom are meant to be graph databases. Imagine you have the human resources database and the payroll database. Each of them can have local constraints. They can use the shared concepts from up above, but for instance, the payroll system has to have it, at least in the US, a social security number and how many marital deductions and your pay rate and all that kind of stuff. And so therefore, before you persist any data, it has to run through some constraints that says, yeah, if you're an employee, we have to have a social security number, start date, pay rate. Over there on the HR side, they especially don't want to have the social security number. that's PII. That's a liability rather than an asset. But we want to have contact information, skills, and all that kind of stuff. And that kind of shows that this constraint management in semantics is typically done with another standard called Shackle. This is where things that people are more comfortable with schema kind of land. Then over here on our left, imagine you do have a relational database that's feeding into this knowledge graph. So there's some structure over there. There's a standard in between. This one is R2RML. There's also some other vendor specific ones, but that's kind of a generalized one. What's kind of cool about it is that's also model driven. That translation is also in triples. It's in the model, but it can run ETL fashion where it goes from the data into the knowledge graph, but the exact same map can run the other way. You can run a query from the center and reach in to the relational database at query time, turn it into triples, and add it to the rest of the knowledge graph, which was on the previous slide. So here it is, putting it all together. We got schema in the existing systems. We've got a way to translate schema to and from the shared format there, the knowledge graph, either ETL or federated. The ontology is what things mean and how they can be related, the complex relationships between them, and taxonomy for all the fine-grained distinctions. And let's see, I'm going to kind of, in the interest of time, we can do case studies in the Q&A if we want, but here, just hilariously, our own company, shame to say, is not yet data centric. There's one little thing in the middle that looks like LB, that really stands for I-beam. We did build a data centric knowledge graph system for time cards, project management, gross pay calculation, because it's very complicated here. But the architecture we built at the time was not sufficient to cover the rest of our landscape. So here's the 20 or so other tools, including a few very specific Excel things that we use to manage staff and commissions and project management, and all that kind of stuff. And of course, QuickBooks and payroll and all these things. Within a year, we hope to have all these things gone, everything just in our next generation of the architecture. And we think, this is going to be the route for many people. One last idea, a plug for a future book. In the course of doing this, you saw QuickBooks there on the previous slide. We started realizing if you're going to collapse all that into a single model and get all your functionality on that model, amongst other things, you have to replace your accounting system. It turns out, and I've implemented a lot of accounting systems over the years, so I'm pretty intimately familiar with what makes them complex and what makes them easy. And we realized that as you turn the corner and say, wait a minute, a data-centric accounting system has an amazing number of advantages. I just wrote an article, it'll pop here pretty soon, on TDAM, which is sort of a teaser about the book. And Steve's agreed to publish the book, so we're promoting it here. So let me just wrap everything up and take some questions. As you'll recall, this is what most current architectures look like, and they look this way because people have been implementing things one application at a time and recreating these silos and then doing this to try and put them back together. There is another way, the way on the right there, the normal path where everybody goes, let's just implement one more application system. They end up in what we call the application-centric quagmire. There's a guy struggling. The more you struggle, the deeper you go. The house on the hill there is data centricity. There's probably only about 1% of all companies that are on this journey at this point, and therefore a pretty good advantage to anybody who goes this route, because the economics are amazingly, read Software Wasteland, you get an idea, 100 to 1, 1,000 to 1. It's incredible. So there's good news and bad news here. I suppose the good news is that all you have to do to implement this is change the way you think. But that's also the bad news. It's really hard. I'm listening to a book on tape right now called Change, and it's exactly about how hard is it for individuals and especially organizations to make true behavioral change, and that's what this is. But it helps to have some enabling technologies like graph databases, semantics, and model driven, because that helps people get out of their comfort zone, because they slip right back to what they're used to. So if you want to get started, here's a couple of thoughts you might want to jot down. We have a manifesto. It's been out there for almost 5 years now, but it's pretty impressive. You could just go look at what all the signatories have said when they sign it. There's a lot of people out there that know this is the right thing to do, and they're kind of struggling to get the sponsorship they need to move this forward. But that, will remind you that you're not alone. I actually changed the dates for this, but go to our website. We've been having an annual conference about if you want to do this, you have to make some changes to your architecture, because you've relied on your applications to solve many of your problems in the past. And we're about to have our 4th annual forum on this topic. It's more on the architecture and the software and the development side than the design side, but it's worth knowing about. The dates have changed. Sorry, I didn't update that. And then finally, as promised, I talked Steve into providing a 60% discount for our books. And the reason is, I've talked to a lot of people who buy the book and then they go out and buy 3 or 4 more to share it. They're trying to get their colleagues and their bosses to buy in on it. And I wanted to make that process easier for them. So if you go to those, Techniques Publishing subdomains there, for either data-centric or software wasteland, if you buy 4, they'll ship you 10. So it's buy 4, get 6 free, 10 for the price of 4, however you want to look at it. It's quite an incredible deal, and do it soon, because every once in a while Steve redoes the math and thinks he loses money on it, but he doesn't. I'm pretty convinced, but you never know. You might backslide. So there you have it. I shouldn't do the appendix. Are there questions now?
Well,
no questions.
That was great.
Whoa.
Yeah, thank you. Thanks for that. So, any questions? So I'll start off with one, which is the organization that you said was in that high percentile, how they're 100% model driven. You went out to see them. Was there any ROI? Like, was there anything that was factual done that showed that they benefited from this and saved money?
Oh yeah, there's tons. One tiny anecdote that I think is amusing, and they became acquired by Standard & Poor's. So they are one of the major divisions of Standard & Poor's now, and they have a sister division that's almost the exact same size. So there's a nice comparable side-by-side study. So this part of Standard & Poor's called Market Intelligence. When South Sudan became a country, and these guys South Sudan's an oil exporter and stuff, so it's not like you can ignore it. These guys had one place to change it, and it was changed over the weekend in every single system that referred to countries. The other side of the thing, 5 years on, it's still inconsistent. Some of the systems have it, and some of them don't. I mean, it's overnight, 5 years. Some of these things are just like that. They're night and day.
Thank you. Question 2 from John. I understand you model the company, not the application. So you can make a data model of the company without any applications.
Yeah, that's a great question. We used to do exactly that. And it takes a long time with lots of facilitated sessions, all that kind of stuff. And we found that it wasn't getting implemented and it was taking too long. So what we actually do now, we have a methodology we call Think Big, Start Small. And the Think Big part says, get enough of the enterprise and do it in a way that you're not going to have to refactor everything in the next project. And how we do that is if we start with GIST, the upper ontology I mentioned. We've now done enough projects and factored what we've learned back into GIST. Most of the what we call covering concepts that you're going to find in most enterprises are already there in GIST. So as you specialize them, you're on pretty solid ground. We then detail it out around the area that we're working on, but the start small, I will do a case study now because it's kind of a fun one. Start small is in some given area, and it's usually a couple of applications, because the immediate added value is usually to integrate things that were poorly integrated before. Even though people have data warehouses and all that kind of stuff, there's a lot of stuff that they just have a hunch. If I could connect up this, and this better, then I could make better business decisions. So so we will typically start in some little area, and in some ways that looks a little bit like what people are calling data mesh now, except it's data mesh from the top down instead of the bottom up. So here's the example: Schneider Electric, gigantic company that makes industrial electric products. They make about 1 million different products, sell them in 140 countries, and it's very complex stuff. These 10,000 volt circuit breakers. I mean, if you put these together wrong, buildings melt and people die and all that kind of stuff. So they had the intuition that they wanted to start with a better configuration management system, because the way they were doing it was incredibly labor intensive and manual and all this kind of stuff. What they would do, because it was so complicated, was wait until the managing director of a country, like let's say Austria, decides that they're now going to adopt a new line of products that Schneider corporate started making last year. Okay, we're going to bring those into Austria now, and we're going to have pricing and promotion and all that kind of stuff. But we also have to know how these products work with the other products that are for sale in Austria. And they'd build these gigantic spreadsheets and get engineers and electricians in there and write all this stuff. And then they had this bizarre format, because the configuration management had to go into SAP, because that was their ERP system. Very complicated, and it took a long time. So there's a couple of things going on. Their intuition was, if we could just get this in a more sensible structure, we could reverse engineer this configuration management process and do something good. So we do that. We designed, we already had the top part of their enterprise ontology. We detailed it out a bit in the area of products. So we didn't do much with HR and finance at this point, although we felt, well, by the time we went there, it'd be okay. And then we detailed out, kind of configuration management. And then sort of like in that process I was showing you there, in fact, it was R2RML, we sucked all the data for all 1 million of their products. And every product has hundreds of physical and electrical characteristics that distinguish it from every other product, and ultimately are what make it compatible or not compatible. All that went into the graph. And then, and we actually worked with these partners. We did build a configuration management system. It was pretty incredible in that we went and interviewed the designers of these products to find out what is it that actually fundamentally makes something compatible. And they told us, and it turned out it was only about a dozen rules. You could put those rules in the knowledge graph, and then you knew before the guy in Austria even decided to start selling it, as soon as you do start selling it, this is going to be compatible with that one. But the other, and so, that's a case study, I suppose. But what was fascinating, after we had done that, we ran a query of the knowledge graph and realized that we'd only, out of the whole enterprise ontology, which had 400 or 500 concepts, we'd only populated 46 classes and 36 properties, so 82 concepts in total, represented all 1 million of their products in exquisite detail. And then we went back and looked. Their existing product catalog had 700 tables and 7,000 attributes, so almost 100 to 1 reduction in complexity, and yet more usable, not less usable. So the long answer to, you don't start literally with an application, because if you start with an individual application, there's a tendency to go into agreement with a bunch of design decisions that were made decades ago, and they usually aren't very good decisions. But in an application area.
Great. Thank you, Dave. Any other questions? We're actually right on time. So thank you very much for the great presentation, Dave.
Great. Thank you.
Thanks, everybody.